Welcome to the Bitdefender Layered Security and EDR demo. My name is Catalina and I'm a product manager at Bitdefender. I will walk you through a demo of how Bitdefender advanced technology layers are able to detect and give you visibility and response options against a real-world sophisticated ransomware attack. We're talking about the Ryuk ransomware. Now, before we look at the attack, it helps to know a few things about the MSP security suite that you will see in action. It includes much more than just AV or AV and EDR. It is a very comprehensive set of security technologies with risk management and hardening layers to reduce the attack surface area, automated prevention and detection layer, incident visualization, and EDR. We will focus only on some of these technologies in this demo. We also use a mature set of machine learning, tunable machine learning, and behavioral detection technologies to block advanced persistent threats or targeted attacks automatically. The Bitdefender multi-layered solution has been consistently proven highly effective in stopping advanced attacks in real-world independent tests. All right. So to see EDR and the layer defense in action, we've set all our other prevention and detection technologies in report-only mode. This means they will not take the automatic block actions they normally would, but you will see all detections at different stages in the attack. I've opened the incident graph, which shows every stage of an attack and makes it easy to understand how it unfolded. You can see at the bottom the EDR detection of a malicious ransomware encryption process. Now, think of EDR as a heat-based intruder detector in your home. It is an important layer, particularly against the most advanced attacks, but you don't want to stop most intruders after they have entered your house and have started doing damage. That is why we focus first on having proactive prevention, and before we talk about EDR, let's see from the top how the attack happens and which layers would have stopped the attack if they were not in report only. Just to emphasize, having efficient automatic prevention or detection means threats are resolved without requiring intervention and before they can cause any potential data breach. And this is not the case with many next-gen or EDR-first vendors, which rely on reactive detection and remediation after the breach has happened. As mentioned before, we will take the attack from the beginning in order to observe its attack phases, and also in order to see all the prevention layers that would have popped in if they were in block mode. To start from the beginning, we will look at the origin of the attack. We can definitely see that Outlook was the process detected as the origin, which means that the attack was received through an email. Now, if we look further, we clearly identify even the attachment that caused this attack in the first place. And we see here that we have our first proactive detection on the CV.m, basically a document, a CV that was received through email, a detection that was triggered by our HyperDetect module. HyperDetect uses a special set of machine learning algorithms designed to identify unknown advanced attacks. If you're very sensitive to breaches, you can tune it to aggressive mode to get the best possible protection at pre-execution. Verifying on the right, we see information about the detection and also some recommended steps. Moving further in the attack, we see that the document was opened, and in most cases users are asked to click on Enable Content, which some of them actually do all the time. Now, what this triggered in the back was ZMD process to be executed, which we can see here in the visualization graph that was detected by Advanced Threat Control technology. Advanced Threat Control is an automated behavioral detection we've perfected for more than 10 years. It continuously monitors all running processes and stops them when a threshold of malicious activity is reached. It also automatically rolls back system changes to the registry, for example. In this particular case, we can clearly see in the command line that was run by this process the malicious intent and, of course, behavior that it had. Looking further in the attack, we see that command prompt triggered a PowerShell process to run and execute basically a malicious command line, which is why it was detected by our fileless attack defense module. Fileless attack defense looks at the code in memory and detects attacks that use scripting tools such as PowerShell or command prompt. It's important because most new ransomware or APT threats are now using fileless because it is difficult to detect by AV or anti-malware solutions. If we look closer at the command line that was run by this PowerShell instance, we see that it further downloads payload from a particular URL, which is usually called a command and control center in the attack phase. It is only now that we can see the actual ransomware, which was brought through fileless methods by PowerShell and executed directly in memory. We can also see in this graph the URL that was used to download the malware from. This was also marked as suspicious by our anti-malware analysis. Now, once the ransomware is executed in memory on the machine, we can start seeing its malicious intent. First, we see that it tries to forcibly stop a process from executing. And if we scroll down to better understand this, we see that the process that it tries to forcibly stop is actually Outlook. We can see this malicious intent as a way to further encrypt the email database, which usually contains very important information for the user and the company itself. A second malicious intent, which we can see in the visualization graph, is the ransomware trying to stop the AV services. By doing this, it can easily start encrypting all the sensitive files on the computer without the chance of being caught in action. Luckily for us, Bitdefender uses strong anti-tampering techniques that avoided this from happening. Moving further in the attack, we see a second attempt to use a fileless attack technique. We see Windows management instrumentation being used to delete all the shadow copies from the system. Some ransomware are able to delete the shadow copies, which are used by some AV solutions to roll back or actually restore encrypted files after a ransomware attack. This makes it impossible to restore the files, so preventing the ransomware is always better. If we closely look at the command line, we can clearly see the malicious behavior and the reason it was detected by our fileless attack defense module. Moving towards the end of the attack, we see that the ransomware dropped its ransomware note on the system. It's now preparing to encrypt all the files and then ask for ransomware for them. We now see the first file that was encrypted by our Ryuk ransomware in this case. Thanks to the type of the file, specifically its extension, which is a mark of each ransomware left on the files that it encrypts, this file was detected by our EDR module, detected of course as suspicious. It now moves to other sensitive files from the system, like transaction databases and even contracts it can find. The incident visualization graph is very important because it helps you understand the attack impact and prove compliance, and also helps you know when you have gaps in protection and address them. We also provide guided investigation through a critical path to make the investigation as easy as possible for our clients. We wanted to make EDR for human beings that doesn't require a security expert in order to be useful. So we provide guided investigations and recommended actions to help you know what you should do to contain or mitigate threats or improve the security posture. Now that we've concluded the visualization of our attack, let's see how we can do further investigation and remediation. As with most malware attacks in the wild, the piece of software that is usually constant is the actual ransomware. What differs a lot is the way to get in and breach the system. So in order to do remediation, let's start from the ransomware itself. On the visualization graph, we click on the ransomware process, and we see that in the right pane, we have a remediation section. In this remediation section, we see several actions that can be taken on the ransomware process. We can kill the process, or we can quarantine the file. We can also add the file to a block list in order to prevent the spread of the ransomware within the entire organization. Adding the file to the block list would mean that the process would be prevented from executing on any of the endpoints within the network. Also, in case of a false positive, there is also the option to add the file as an exception. We also have the option of using the sandbox analyzer to further investigate the behavior of the ransomware. We can see on the right that the ransomware was sent automatically to a sandbox analysis. And if we click on the View Sandbox report, we are immediately taken to a very comprehensive report which details the behavior of the ransomware. Our cloud-hosted sandbox uncovers elusive threats hidden, for example, in Microsoft files with macros. It can detonate the suspicious items in a safe environment and provides a verdict and a full analysis of every action the item is trying to take on the system. We can see in this detailed sandbox report a lot of information about the system changes, about the behavior in terms of IOCs, and most importantly, we can also see what the end user experiences when the attack unfolds on his endpoint. Now that we've seen how we can do remediation and further investigation on the ransomware itself, let's see what options we have at the endpoint level. If we click on the endpoint, on the right pane, we see the remediation actions we can take. We can do a remote connection session and connect to the host. And we have a few commands that can help us understand if the attack is still unfolding, if the malicious processes are still running. And also we have some commands that can help us kill and stop the attack from unfolding on the system and thus stopping it from unfolding on other endpoints within the network. For example, we can see all the running processes on the target endpoint, we can terminate running processes, and so on. Going back, we can see one of the most important remediation actions we can take once we realized an endpoint from our network has been breached. We can isolate the host in order to make sure that the attack does not unfold on other endpoints within the network. In the right pane, we can also see device information and also patch information, which can provide us insight into missing security patches and also missing non-security patches on the specific endpoint. We have a direct actions of viewing the endpoint, patch status report to further understand more, or quickly install patches that are missing in order to harden the endpoint directly from the EDR incident. Once all the steps have been taken, investigation, remediation, and hardening of the system, we can go ahead and restore the endpoint, which will allow it once more to communicate with all the other endpoints within the network. EDR's main purpose is to identify security breaches early before attackers can get to their objectives, because the consensus in the industry is that it is impossible to prevent 100% of attacks. An attacker with time resources will get through in the end, and sometimes they may not use malware. It can be an insider threat, for instance. To detect these targeted or APT attacks, Bitdefender EDR correlates information from many sensors and shows suspicious activity as incidents that could indicate a breach, and they are prioritized based on a confidence score. Additionally, advanced behavior baselining technologies help detect incidents by identifying anomalous behavior that can indicate an attack. This concludes my demo, which I hope has been useful for all of you in understanding how a complex attack can be visualized, investigated, and also remediated easily by using Bitdefender EDR.